So in this video where we discuss the mean value theorem for integrals, we want to talk about what the mean value theorem is, but also we want to apply that to find the average value. You can remember when in the page in Canvas where we discuss what the mean value theorem for integrals tells me. We talked about pouring the sugar, right? And so and that's just kind of an analogy I like to use. You imagine we've got this container, right? And as you pour the sugar into that container, it kind of piles up, into kind of a mountain type thing, right? Kind of just a hill, right? Just a pile of dirt. And so, or in this case, sugar. So what happens is we take that container and we shake it out, and some of this peak sugar is going to fall into these areas of these low areas. And so we have this height, and we say that this dashed line, that is the average value, and that's what we're talking about in this theorem. So this stuff up here, all the stuff above that dashed line, gets settled into these areas of low points, and this hill, this pile looking thing, now becomes just a kind of a flat topped rectangle. So what we want to be able to do is identify what is that average height, right? What is that height where everything would settle out, so to speak. And that's conceptually, that's what the mean value theorem is telling me. Now, mathematically, the mean value theorem says this: the average value of a function is given by this thing, 1 over b minus a times the integral from a to b of f of x dx. Okay, so we're going to use this as we go throughout some problems and find the average value and so forth. So here's a problem where we can use some geometry to help us out here. It says find the average value of the function, okay, this thing right here, on the interval 0 to 8. And we want to use geometry to do that. So recall what we said about the average value. The average value is 1 over 8 minus 0 times the integral from 0 to 8 of 4 minus 1/2 x dx. Okay, so really what we mean when we say use geometry is we're going to use geometry to find out what this value is, right? That I've kind of underlined in yellow. So that, right, that thing that I've underlined in yellow is just the area of this triangle. And the area of this triangle is going to be 1/2 the base, which is 8, times the height, which is 4, right? Here's our base and here's our height. So 1/2 of 8 is 4. 4 times 4 is 16. So the average value is actually going to be 1/8 of 16, or that average value is going to be 2. So if you go back and look at this triangle, right, and you think about what we said in terms of something settling and that kind of thing, all of this stuff above is going to settle down here in this region right here. So this stuff is going to, if I shake that container, what's up here is going to shift down into this area right here, and we get this nice rectangle. And that height, the height of that rectangle would be 2, and we base that off of what we were able to find right here with our average value function. Here's another problem where we do some of the same stuff. The difference here is that our shape is, it's not a triangle anymore. Our shape is a trapezoid, okay? So this trapezoid has a formula of area equals 1/2 the height times base 1 plus base 2. Okay, so using this, right, we can go in and identify what we have right here from 0 to 2. And this is what was on our interval, right, 0 to 2, of x plus 2 dx. Okay, so using this formula, we get this. And then in order to find the average value, we're going to multiply that by 1 over 2 minus 0. Again, this is from our average value function. So here's what the mean value theorem says theoretically, right? If f is continuous. Now notice it didn't say anything about being differentiable. It just said if it is continuous, On the interval, it's a closed interval AB, there's at least one point C, right, on that AB interval. In other words, C is an X value between A and B. Okay, if A is here and B is here, C is somewhere between those two, such that the function value is equal to the average value. Okay, so what we want to be able to do is, let's go back to this one here. We said the average value was 2. Well, I want to find out where is the X value where that height occurs, right? In this case, it looks like it's going to be somewhere around 4. So the mean value theorem is going to help me find out what the X value is that gives me that average value. So there's two things going on here, okay? One is I'm going to use this thing to find the average value. The mean value theorem is going to help me identify where that height occurs. In other words, what is the X value where that height occurs? So if we look at this problem, it says determine if the mean value theorem for integrals applies on the interval from 0 out here to 3. And we've got this, so it's a parabola, right? And then all of a sudden it turns into a line. And if we asked, is this function differentiable everywhere, then we would say at this cusp where the parabola and the line meet, it is not differentiable. However, our theorem didn't say anything about it being differentiable. It just said that the function needed to be continuous. And so if I find the limit from the left and the limit from the right, I see that they're equal, and I can see that the limit equals the function value. So yeah, this theorem would apply. Here's a question you can read, very simple question about just the mean value theorem in general, but this is really what we wanted to focus on. The average value of the function is equal to 1 over b minus a times the integral from a to b f of x dx. The mean value theorem says that there's some c value that would make this true. So I'm going to apply what I know about the average value and figure out where that thing occurs. This says find the average value of the function 4 minus 1/2 x on the interval 0 to 8 using integrals. So I already know what this answer is. We did this problem earlier. What I need to do is use what I know about integrals to figure this thing out. So the integral of 4 is 4x, and the integral of 1/2 x is just going to be 1/4 x squared. And we're going to evaluate this thing from 0 to 8. So you can see where they come up with the 1/4 x squared. So plugging 8 into this, right, gives me 32. So 8 squared is 64, and 64 divided by 4 is, let's see, 64 divided by 4. Is that not an even value? I don't guess so. Let me double check. It's been a long day of math, and I have to think, yeah, it's 16. Sorry about that. I've had a long day of doing math, and sometimes my brain just stops working. So 32 minus 16, we know to be 16. 16 divided by 8 is 2. So again, we did this mathematically. We did it geometrically, so we can see that those match up. Here's a trig function, and we want to do one of these just to make sure that we know kind of how to use the calculator, how to approach these type problems. So in this one, we're finding the average value of sine x on the interval 0 to pi over 2. So I'm saying, by the way, I'm saying interval, okay, interval, and this thing is an integral, all right? This thing right here is an integral. So we have 1 over b minus a, right, 1 over pi over 2, and we're integrating sine x dx from 0 to pi over 2. So if you take the derivative of cosine, you get negative sine, right? So the antiderivative of sine is negative cosine. I'm going to evaluate that from pi over 2 to 0. So plugging in pi over 2 gives me negative cosine pi over 2 plus cosine of 0, right? Because there's a double negative right here. The cosine of pi over 2 is 0, and the cosine of 0 is 1. So our average value just turns out to be 2 over pi. So the mean value theorem takes this one step further, and it says, look, This is the average value, and I can set that equal to the original function to find out where that occurs. Now remember, in math, when we say where something occurs, we're talking about an x value. So let's take this thing right here, and it says find the point on the interval 0, 8 guaranteed by the mean value theorem. Okay, what is that C value guaranteed by the mean value theorem? Well, we've already found out what the average value is for this thing. We found that out to be 2. We did that geometrically and mathematically. So what I'm going to do is take the original function, sorry, my computer's lagging a little bit, 4 minus 1/2 x, and I'm going to set that equal to the average value. So I go in, I multiply everything by 2. 8 minus x equals 4. I'm going to move the x over here and the 4 over here, so I get 8 minus 4 equals x, or x equals 4, right? And they use c, which is fine, right? We substituted c. In other words, the answer is 4. If we do that same thing for this trig function here, things work a little differently. We're going to have the function, right? Not the derivative, not the antiderivative, the function equal to the average value. And in order to figure this thing out, on your calculator, you have to do the inverse sign, second sign of 2 over pi. So I wanted to take a minute and show you exactly how to do that. I'm going to pull up my calculator. I want to make sure that I'm in radian mode since I don't have degrees. I'm going to do 2 divided by pi. Just hit the pi symbol, and equals, right? So I got to do 2 divided by pi equals. Now I'm going to do second sign, and I get 0.6901, right? And that matches up with what we have down here, 0.690. So the question becomes, where on earth did we get 1.206? Well, that has to do with the fact that sine is positive in the first and second quadrants. So what I'm going to do is I'm going to take this value and I'm going to subtract it from pi. Let me double check. Hang on a second. 1.206. So here, graphically, let me show you what I have here. So we've got this angle 0.690, and there should be another angle over here in this quadrant that matches up to that, okay, this would be pi. So finding that second value right here, 1.206, that one's got me stumped. I'm going to come back to you and figure that one out, okay? So we'll talk about that 1.206 in the next video. For now, though, take a look at your next steps in Newton. I'm not sure you're going to have that issue with the 1.206, but I'll come back and explain that just briefly.